Hello everyone. So this is a lecture on transportation problem. So this is the first part. It's with respect to syllabus. This is from the unit 3. So I am going to take some basic concepts of transportation problem and some problems related to the transportation problem. So we will discuss that and we'll see how the concepts are there in this transportation problem. So we'll go with the PowerPoint here. Okay, so we'll start with the definition. So the definition tells transportation problem is a special kind of LP problem in which goods are transported from set of sources to a set of destinations with objective to minimize the cost of transportation with subject to supply and demand. So the problem here is there is some set of source and there is some set of destinations, and we are supposed to transport a particular product from source to the destinations, and the source are more than one and destinations are more than one, and the objective is to minimize the cost that is involved in transporting the products from source to destinations. So that's the objective of the transportation problem. So going ahead, so there are some notations that will be used in further slides. So what we are using that is m, number of sources, n, the number of destinations, and a of I is it's a number of sources that are supplying a product, and bj it's a demand and the number of destinations where the product has to reach, and c of ij is the cost of per unit the product what we are transferring from source destinations. For each unit of the product, the cost is represented in the form of c of ij. That means the cost involved in moving a particular unit of or per unit from I source to destination j. So that is using cij, and we have xij, that is total number of units we are supposed to transfer from source I to destination j. So these are the notations we are going to use in a further slides for our better understanding of the problem. And the mathematical notations of this transportation problem is given by the z, the minimization symbol z is equal to summation of I is equal to 1 to m, and which is again summation of j is equal to 1 to n from c of ij to x of ij. So this is a mathematical notation that represents the transportation problem. Okay, so the next is general form of transportation problem. So graphically this is how we represent the transportation problem. So we are having a set of sources, so which are a1, a2 and up to am, and from these sources we are supposed to transfer a product to destinations. The cost involved is c of 11, c of x of 11 to c of mm to x of mn. So together means like including with the cost and the total number of products per total units together contributes to the total cost involved in moving product from source to destination. So this is the pictorial representation of the transportation problem, and we are also having something called as the cost matrix, which tells us from source I to the source j what is the cost involved for every unit of product. Okay, so that's a cost matrix. So this cost matrix is what we need to understand, because this is what we will be using in solving the problem later on. So that's a cost matrix, and again we are having constraints here. Obviously all the LPO problems are part of the constraints. So even this transportation problem is having constraints. What is that constraint is summation of j is equal to 1 to n x of ij less than a of I, where I is equal to 1 to up to m. And again, so means the total units what we are supposed to give, it's obviously it has to be lesser than or equal to the sources what we are having, and the total units what we are supposed to supply to the destination, obviously to the demand, it has to be more than what we are having. Okay, so that's what this notations mean. This is the constraints what we are having. Okay, and the types of transport problem. So again we are having problems classified into two categories in the transport problem. One is called as the balanced transport problem, and another is unbalanced transport problem. What is this balanced transport problem? So the total number of supplies what we are having, that should be equal to the total number of demands. Means the sum of supplies of all sources should be equal to the sum of demands of all destinations. So mathematically this is the symbol represented here. I is equal to 1 to m e of I, it's a total number of supplies, is equal to, it's a total number of demands, b of j. So if in case this is not equal, means sum of supplies are not equal to sum of demands, then we are having unbalanced transportation problem. Okay, so two categories are there in transport problem, that is balanced and unbalanced. Okay, so here we are having an example for what is the balanced and unbalanced. The first one is the example for balanced. So this is the cost matrix what we are looking at, and so the left side we are having the sources 1 and 2, and the destination at the top, which is representing as the form of rows. Destinations are 1 and 2 here, and this number represents the cost for every unit. Okay, every unit of product from source 1 to destination 1. Okay, the similar thing applies here. So the cost matrix is given is 30, 50, 35, 70, and the supply and demand. Okay, so the supply is given as part of the column here, and demand is given as part of the row here. So now if you notice that if you add up this total supply, we get it 500, and the total demand, it is 500. So it means the total value of demand is equal to 500, the total value of supply is 500. So it means that supply is equal to demand. Okay, the sum of supply is equal to the sum of demand, therefore this we call it as balanced TP. And there is another example where we don't have this condition having, means the demand is not equal to supply here. So the total number of supply here is 500, and the total number of supply is 500 and the total number of demand is 400. So there is a mismatch here. So we call this as unbalanced transport problem. Okay, and next, how do we convert this unbalanced transportation problem to balanced transportation problem? So and I'm taken both the examples where demand is greater than supply and supply is greater than demand. So the first case is where demand is greater than supply. So the demand is 600, total total value of total sum values of demand is 600, and total sum values of supply is 500. So it means that this demand is more and supply is less. So it means that demand is more and supply is less, means the supply now it has to have some extra values, dummy values, to match with demand, and that's what we try to do in this next matrix, cost matrix, where we try to add dummy supply values 0 0, means the cost is 0 0, but the value of that supply is 100, means the cost is 0, the cost what we added in the matrix is 0, but the value of the supply we are added is 100. Okay, so this is a dummy actually. So to make this unbalanced balance, we are adding this supply value, but the cost involved for this dummy value what we added, it is 0 here. So now this has become a balanced TP, because now we are having 600 is equal to 600, the demand is equal to supply here. And the same thing applies when we are having other way around, means when the demand is less but the supply is more. Again, so in this case we are going to add an extra column, and that extra column will be having dummy cost values which are zeros and dummy demand value, because now demand is less, we are adding dummy demand value which is 100 in this case. To make it balanced, we need to add dummy value of 100. So this is example of how do we convert unbalanced TP to the balanced TP. Okay, so the method to solve transportation problem, we are having two phases in solving the transportation problem. The first phase is called as finding the initial basic feasible solution. In that we are having again three algorithms to achieve this, making the given transportation problem into initial basic feasible solution. And then second phase is to optimize whatever solution we got in the phase 1, that has to be optimized, and the second phase is to optimize the initial basic feasible solution obtained in phase 1. So again, in the phase 1 we are having three algorithms, and in the phase 2 we are having one technique we are going to discuss. So in this lecture I am going to cover only the phase 1 part. So with the examples we will take each method and we will try to discuss how it works. Okay, so this UV method we will be having one more video. I will share that, and we will go through that. Okay, so the northwest corner cell algorithm method, the first one. So the algorithm is given here, so I don't want to read it. When we will discuss with the problem how this algorithm works. And similarly there is a least cost cell method. Again, some 9 steps are there. So directly we get into the problem and try to understand how this algorithm is there directly with the example. And the third one is Vogel's approximation method. So once you understand this algorithm technique with example, and if you refer back to this algorithm, that will be more easy to understand what this algorithm is given. Okay, so we will go to the example directly. The first one is a northwest corner cell method. The thing is, we should check out whether the given cost matrix is balanced. That's the first thing we should do. That's a preliminary check. If it is not, then we are supposed to convert that unbalanced TP to balanced TP. So the example what I have taken is already a balanced TP. So its the cost is also, means the supply and the demand is also given here. So it is same. So this is a given matrix. So we are having the matrix with 3 rows and 4 columns. Okay, so I will be referring to this cell values as Cij in format only, means C11, C12 in this form, so that you can understand C12 means C first row second column. Okay, so I will be using this matrix cell notation in the form of C. Okay, so what is our first step? Okay, the first step is, as a vertex northwest corner cell method, in this matrix select the northwest corner cell. So what I have done is I have taken this cell and compare the corresponding supply value and demand value, and in that select the minimum as X value and put that value, the minimum what you have taken, in this case it is a demand value, that is 250. Add that 250 here, okay, in the selected cell, northwest corner cell. Then you subtract that X value with the demand value. So X value is 250 here, and 250 is subtracted with 250, we get the result as 0. And the same thing you do in the supply part here. So 300 minus 250, so we get 50 here. Okay, so this is the first step. Then going ahead, so now just I will go back. Okay, so after doing this, now we are having the demand value as 0 in case of the first column. The demand value is 0. So the column or row which has the demand or 0, demand or supply as 0, you need to delete that particular column or a row. I repeat this: any column or a row or a supply or a demand, after performing this operation subtraction, it becomes 0. So you exclude that particular column or a row. So in this case, the demand has become 0. So the demand is part of the column here, the first column. So you exclude this column, means you need to remove this column, and whatever is left out part in the matrix, you carry this matrix to the next step. Okay, so we call this as a deleted, means the column what we are deleting, it becomes a deleted cells or deleted column. Okay, now going ahead, now we can notice that I am retaining that number, so that these numbers I need at the end, so that the values what we are putting, the x values in the northwest corner cell values, so we need to refer back that values to get the final initial basic solution matrix. Okay, so I excluded that, and this is matrix I get, and the same procedure I am going to repeat. Again, I am going to take the northwest corner cell, or in another we can call that as first row first column cell, and you take this and compare the corresponding supply and demand values. Choose the minimum of this. So in this case the supply is minimum, so take the 50. So this becomes x value. Put that x value into the selected northwest corner cell, 50 here, and that's what is given here. 50 is added here, and you subtract that 50 value with supply and demand. So the supply becomes 0, demand becomes 300. And now again same procedure. So whichever row or column becomes 0, you exclude that row or column. Okay, now we go ahead this. So this we need to repeat until we reach a stage where there is only one row or only one column left. Okay, so again we proceed further on this. Now we are having one row deleted, one column deleted again. So I am going to take the northwest corner cell, which is nothing but C of 2 here. So I make the comparison with supply and demand, and the demand is the least here. Put the 300 value here at the C22, then subtract this 300 with supply and demand, so this becomes 100. New value is 100 again, so the demand becomes 0 here. So exclude this column, the value of demand has become 0 here. Okay, column number 2, you exclude this column, you delete this column. Okay, so once we delete it, again we have reached a stage where it's a 2 into 2, again means there is one more step we need to go ahead. Again you take the northwest corner cell, compare the supply and demand, and the supply is less here, so this becomes x value. Put that x value to the northwest corner cell, which is nothing but 100 here. So subtract that value with supply and demand, so 100 minus 100 0, and similar thing with demand here. So 400 minus 100 becomes 300. Now this row has become 0 supply, so exclude this, and now we reach a stage where we need to terminate the algorithm, because we meet the condition of one of the means either the row or column becomes 1. Okay, now we are having only one row. Okay, two columns are there, only one row. Now whatever the values are left here, you directly take that values, means the demand is having 300 and 200. So whatever the cost is there with the corresponding column, you multiply that, means, or you directly put that values to the corresponding cells here. Okay, so this 300 value is added to the C33, and the 200 demand value 200 is added to the cell C34. Okay, now again we need to trace back all the values what we have removed as part of the procedure, and the values, the cost, the demand and supply values what we added to the northwest corner cells, we need to again trace back to the original cost matrix. And when we do that, we have this matrix. So if you notice this 3, the C11, the cost was 3, and the corresponding supply or demand value what we subtracted, it is 250. And the same thing applies for this 150 is either demand or cost value what we subtracted, x value. Again you put it for this 6, 300, 500, so 300 to 200. So again the original matrix is added now with the x values as part of the cost matrix here. Now these values are taken to find out the initial feasible solution. And what is that cost? Total cost is 3 into 250. So how I got this 3 into 250? So 3 is there here, the cost, and 250 is the total number of units or total number of x values that is going to be transferred from source 1 to destination 1 with each product cost of 3. So it means total cost from 1 to 1 is going to be 3 into 250. So that's what I'm trying to do here. Total cost is equal to 3 into 250 plus 1 into 50 plus 6 into 300 plus 5 into 100 plus 3 into 100 plus 2 into 200. So the final result is going to be total cost of rupees 4,400. So this is called as the initial basic feasible solution, and the algorithm what we used is northwest corner cell method. Okay, so we go to the next method, that's called as least cost cell method. If you understand the first method, understanding second method is not a difficult one, because a slightly modified technique or the logic is applied here. In case of northwest corner, we were using the first cell, first column, first row cell concept. The same technique is used, only thing is the selection of cell is different in case of least cost cell method. Now I have taken the same problem, same cost matrix is there, and now how we are going to select is, as the word tells, least cost cell method, I am going to select the cell which is having least cost. So in this case, in this example, the least cost is C of 1 2, the cost is 1 here. So I select that cell C of 1 2, and I am going to compare the corresponding supply and demand value, and in that the least one is selected and I subtract that. Okay, so this supply value 300 becomes x value, and I am going to put that here, and that's what I have done here. So I am going to put that 300 into this C of 1 2 cell, and this x value is subtracted with supply and demand. So when it is done, the supply becomes 0 and the demand becomes 50. Okay, and again I'm going to delete that corresponding row or column where the supply or demand has become 0. So in this case, the supply becomes, the supply value has become 0, so I'm going to exclude this complete row. So when I do that, so this is what I get. So it is the first row is completely deleted, so we are left with 2 rows and 4 columns. And again I'm going to do the similar comparison. I'm going to find out a cell with the least cost. So in this case I'm having 2 cells, so I can have any cell of my choice. So you can choose any value, there is no particular procedure to choose a particular cell here. So I'm going to take the first one anyway. So I take this C of 2 1 cell and I compare the corresponding supply and demand value, and the least is the demand value 250, and you take that, put that 250 value as x into this C of 2 1 and subtract that x value with the supply and demand, and the supply, the new value is going to be 150 and the demand is going to become 0. So remove this, the first column, because the demand value has become 0. So after removing that, this is a new cost matrix we get. Again the same procedure. Now obviously the another 2 I am going to pick as a least cost cell. So when I do that, and I am going to compare with supply and demand value. So the demand value 200 is minimum here, put that as x into this least cost cell and subtract that value with supply and demand. So the new value of supply is 300 and the new value of demand is 0 here. So again the same procedure. The demand has become 0, the column, the fourth column is deleted, so we are left with 2 and 2 rows and columns. So again we are having 2 values with a similar value, same values, so you can choose any value, no problem there. So I take this one of the value. So this cell, again I'm going to compare I'm going to check the supply and demand. The minimum value, the 300 supply, is taken and put it as x value here into this least cost cell, C of 3 and subtract that value with supply and demand. So the supply becomes 0 and the demand is 100. So exclude this row, the third row, completely, because the supply has become 0. And now we have reached a stage where we are having only 1 row and 2 columns, and now whatever cost and the demand and supply is left, you multiply that demand with the corresponding cost value here. So I have taken that 50 and I have put that as x value into this C of 2 and I have taken this 100 and put into C of 2 okay. So now the new matrix, cost matrix, after applying this cost values, we get the feasible solution, initial feasible solution, which is of this form. So 1 and the corresponding supply demand value is 300, 2 and 250, 6 and 50, 5 and 100, 3 and 300, 2 and 200. So now if I am trying to find out what is the cost, the total cost of applying this algorithm is 1 into 300 plus 6 into 50, 5 into 100, 3 into 300, 2 into 200 plus 2 into 250. So the total cost finally what I get is rupees 2900. The same problem compared to the earlier method, northwest corner cell method, we are having less cost for the same problem. So it means this least cost cell method is having more optimal solution or better solution compared to the northwest corner cell method with respect to this problem. Okay, so going ahead, the next one is Ojel's approximation method, which we call it as the WAM. This is quite similar to the earlier method, the least cost method, but one more parameter is added here, that's called as the penalty. The selection of cell for making the comparison of supply and demand, it is based on the penalty value here. Okay, so how this penalty is determined? So I have taken the same problem here, whatever we have done for the first two techniques, first two methods, the same problem is taken. One extra parameter is added, penalty. So the penalty is found for both rows and columns. So you need to add one extra column and row just next to the supply and demand. So how do you find this penalty? Okay, so this penalty of column and this penalty of row. So how do we do this is, in the every row take the minimum, first minimum and second minimum values, take the difference of that and put that here. Okay, if you refer to this first row, the first minimum is 1, the second minimum is 3, and the difference of the first minimum and second minimum is 2, so the penalty becomes 2 for the first row. And the penalty for second row is, the first minimum is 2, second minimum is 5, the difference of the first minimum and second minimum is going to be 3. And the same thing for the third row, the difference of first minimum and second minimum, the penalty is 1. So this is the row penalties what we have done, 2, 3, 1. And same thing for column penalties, same procedures. Find the first minimum, second minimum. The first minimum is 2, second minimum is 3, and the penalty is 1. And the first minimum is 1, second minimum is 3, penalty is 2. The first minimum is 3, second minimum is 5, the penalty is 2. The first minimum is 2, second minimum is 4, the penalty is 2. So these are the column penalties, these are the row penalties. Now we need to compare both the penalties, row penalties and column penalties, find out the maximum value in the penalty. And again, if there is two values with the same penalty, means if you find out row penalty and column penalty having the same values, then it's your choice, you can make any choice whatever you want. There is no again particular procedure to make the tie there. Now in this case we don't have that problem here. So now 3 is the row penalty and it's the highest value. Now this row is selected, and in that row select the least cost cell. Okay, so if you go to the next step, that is there, so it means this cell is selected. And again the same techniques what we have done in the previous techniques methods, again compare or means find the minimum between the supply and demand, and whatever minimum is there, put that value into this selected cell as x value, and subtract that x value with supply and demand. So in this case we get 150 as a new supply value, 0 as a new demand value. So once we get this 0 in this demand value, the corresponding column is removed, and this is what I get, the corresponding column is removed. And now this is a new cost matrix now, and I am supposed to find the new penalties. Okay, the same thing I have done here. So there is the row penalties, so difference between the first minimum and second minimum, 1 and 4 difference is 3, 5 and 6 difference is 1, and 2 and 3 Okay, 2 and 3, it should have been 1 here. There is some mistake here, kindly ignore that. Then the column penalties 1 and 3 is 2, 3 and 5 it is 2, 2 and 4 it is 2. Okay, so again I need to make a comparison between the row penalties and column penalties. Choose the maximum. The maximum is 3 here. So this row is selected. In that row, the minimum is the C of 1 to cell. The C of 1 to cell is selected, and compare with the corresponding supply value and demand value. So the supply value is 300 and the demand value is 350. So the minimum is 300. Put that value as X into this C of 1 to cell and subtract that X value with supply, we get 0. Subtract with demand value, we get 50. So the supply is 0 here. Remove or delete that complete row. So the new cost matrix is this. Find the penalties. So the penalty new row penalties are 5 minus 6, it is 6, 6 minus 5 it's 1, and 3 minus 2 it's 1. Same thing here, 3 2 7. So now in this case the maximum penalty is 7. Again we are going to make the comparison and take the least one. Okay, so the 2 is the minimum value here. So compare the 500 and 300 value. 200 is the minimum. Put that 200 value as the X value into this C of 34, and when you put that 200, so subtract the 200 with demand and supply. So 200 value becomes 0 here. The 500 becomes 300, and the new cost matrix is of this form. Again we are left with the 2 into 2 matrix. Again find the new penalties. So we have 1 and 0, 3 and 2, it's a column penalties, and the maximum is again the column penalty 3 here. Take the least one. So C of 3 2 is the least, and compare the supply and demand values. Take the minimum supply or demand. So minimum is demand value here. Put that value into this C of 3 2 column, 3 2 cell, and that becomes X value here. So 50 is added here. Subtract that 50 with supply, it becomes 250 here. With the demand it is 0. So exclude this or remove this, delete this second column because it is the demand value is 0. And now we have reached where we are having only one column and 2 rows are there. Okay, so whatever values of supplies are left, put that values as X into this corresponding rows. So 150 directly becomes as X value here in the C of 2 3, and 250 as X value into C of 3 3. And again putting the original matrix, cost matrix, with X values, we get this matrix in this form. And finding the total cost in the similar way what we did in the earlier cases, we get the value as rupees 2850. Okay, so this is the initial feasible solution using the Vogel's approximation method. Okay, so after doing this, it means that we have done with phase 1. So what we are left with is the phase 2 method, and the phase 2 method I am going to discuss as part of second video. So by the time you try to solve more examples using these 3 techniques, so that you get more comfortable. And in the phase 2 technique also we need to make sure that we are confident about the phase 1 techniques, because these techniques are again reapplied in the phase 2, and again there is a continuation in the phase 2. And in the phase 2 we are going to discuss the UV method, so I will try to discuss that in the second video. So that's it on the first part of this transport problem, and the reference for this lecture is Paneer Selvam Operation Research second edition PHA publication. Thank you. If any doubts are there, please give queries or questions in the WhatsApp group. Thank you.